Let's think about heap sort. Heap sort is similar to the selection sort. Selection sort is using swap by checking the linear search, find the max, then swap with the last. Find the max and swap with the current last. We are going to do almost the same thing in the heap sort. We are going to find the max and swap with the current last. That's things. Well, it's very easy because index 1 has always a maximum value if we use makeHeap. So whenever you need to swap, you just need to find the first value. Then swap with the last. Only one thing is you have to keep this list as heap all the time. You have to make sure this list is all the time heap. That's overhead to make heap. That means extra work. That's why HeapSort has yes for overhead. You have to do some more work before you start. Let's think about how fast the HeapSort is. Actually, HeapSort does not check every single one. If you see the heap down, it was checking only like less than half of the data in the most of the time. So HeapSort is also HeapSort is using heap down, so it's not going to take long. First and last, you are gonna swap. Then when you make it heap, it is just log n. So you are going to do log n times, because each time you are going to get current last. Then average is also big O and log n, because you anyway need to make heap. So you have to check something. Worst case is O, so it is very stable. Then it does not use extra space. It does not really build tree. It just do little overhead. That's it. So HeapSort is very useful. But our Python, in my knowledge, is using quicksort for sort. Let's think about coding the HeapSort. You need to make heap. Let's see if this is a heap. Actually, this is not heap, so I'm going to make it heap. Make heap is kind of easy. I'm going to use from the last index, that means size. Then size divided by 2, so I'm going to start from index 4. From index 4, I'm going to do heap down. So at index 4, heap down. Heap down. We already did, right? So compare two children, bigger children, compare with parents. I need to swap. After I'm done with the number index 4, I'm going to do index 3, then heap down. So start from index 3. Compare two children. Oh, 85 is bigger. Compare with the parents, 2 and 85. Yes, swap. Now I'm going to start with index 2. Let's see index 2. Compare two children, 99 and 80. 99 is bigger, so compare with index 2 parents. So because 99 is bigger than 1, so swap. Oh, it's not done because it has more. So now starts from index 4, has value 1. Then look at the two children, so heap down again. Then 17 and 16. Oh, 17 is bigger, so compare with the parents. And 17 is bigger, so swap. Then there's no children, so stop. So heap down is done. Now it's time to do with k equals 1. Now let's check from the index 1. Compare two children, 99 and 85. Oh, 99 is bigger, so compare with the parents. Then if it's needed, swap. Stop? No, it's not stop. You keep doing the heap down if it's in the middle, if it has children. Now it has two children, 17 and 80. 80 is bigger, so compare with the 80, swap. Then it does not have a child, so it's done. Now let's see this data. 99 is greater than 80 and 85. 80 is greater than 17 and 30. 85 is greater than 84 and 2. 17 is greater than 1 and 16. Oh, this is a max heap now. So the result is here. Let's write the code for this one. I start from size divided by 2. Then go to up to 1. If I say 0 in the range, the second number is not inclusive, so it goes up to 1. Then negative 1 means direction, so it's going to, the k will decrease by 1 each time. In the heap down, I'm going to pass array, then current k value. So first time I pass 4, then 3, then 2, then 1. Size is always the same. In this case, the size is 9, last index. Now, if you made a heap, it's time to start the heap sort. So makeHeap is the first step. Now we start sorting. Number 2 is sorting. Let's see here. We guarantee index 1 has a maximum value, so swap first and last. So this is the first step. So we guarantee last index is now max value. Then you are going to heap down until 8. So if you see here, actually you had 1, 80, 85, 17, 30, 84, 2, now up to 16, not 99. Then if you start to heap down from the 1, you are going to see you are going to swap with 85, then 1 will be swapped with 84. So you see 85, 80, 84, 17, 30, 1, 2, 16. Now it guarantees 85 is the max because you made max heap. Then you are going to swap. So this is number 2. Then swap with 85 and the current last. So now it guarantees index 8 is done. Now you are going to restart from the current index 1 and you are going to do heap down. So from 16, compare 80 and 84. So 84. So 84 becomes now root. Then from 16, you have to restart. 16 child is, it's index 3, so index 6 and 7. 16 is bigger than 1, 2, so you don't have to do more. Now let's see. 84 is now max. Then you are going to swap with the last. Current last is actually index 7. Then after swap with the 2, you are going to start from 2, the heap down. You are going to compare to the children, 80 and 16. So now 80 becomes root. Now you have 2 in the index 2. So index 2 to the child is 4 and 5. Compare 17 and 30. 30 is bigger. So swap with 2 and 30. Then you are going to start from 2 again, index 5 again. Then there's no child. So you stop. Then you are going to swap first and last again. So current max 80 will be swapped with 1. So 80 is now large. Then you are going to start from 1. So heap down. So 1. Children is 2, 3. So 30 is bigger. So you are going to swap with 30. So from the index 2, because now you swapped with index 2. Index 2's children is 4, 5. 17 is bigger, so you're going to swap with the 17. Then you're going to start from index 4. There's no child because we do not care about already fixed. Then next time, you're going to have max 30 with 2 swap. Then from 2, you're going to heap down again. 17, 16, 17 is bigger, so you swap with the 17. So starts from index 2. Index 4 and 5, but there's only 4. Then 2 is bigger, so you stop. Now, current max is 17, so swap with the current last index 4. Then you're going to heap down. So from the index 1, you compare child 2 and 3, index 2 and 3. 16 is bigger, so you swap. Then you are at index 3, but there's no more child because your size will be only up to here. Now, you're going to have max 16 and swap with the current last index 3. Then you're going to do heap down 1 and 2. You're going to compare 2 is bigger, so use and index 2 does not anywhere to go, so you stop. Then finally, you're going to say you swap max with index 1, current size. So here is the full trace of maximum with the max heap sort. So you can see that first step is swap first and current last. Current last. Then current last will be reduced, decreased by 1 each time. Then you are going to do heap down until you are done. So this is one phase. Swap with last, then heap down. Then there's a level assignment. You are supposed to do part 1, part 2, do both of them. If you see here, all the methods are in the shellcode, and if you see the main method, you are going to see all methods are void method, does not return anything. You are going to just change whatever array is passed. Only one method is a return method, that is a void method. I do not want you to use any other library or special method except random, because you have to generate random numbers. If I show you the shell code as a main method, I do not recommend you change this shell code. The reason I created 101 because we want to use index 1 through index 100. Index 0 will be dummy. Then sample output is printing the random first, then max heap. Then sort will be ascending order, the sorted data. Then finally, it should return the correct result if the array is sorted or not. So this is the sample output. Each line you are going to print 100 items. Phew.